Good afternoon, everyone. Welcome to this webinar. We'll start in a minute. So just allowing you all to enter slowly. And in the meantime, I'll use this time to share my slides. So I'll share the whole screen. I hope you can see it properly. Okay, yes. Great. So it's 2:30. People are still joining, but let's start. In any case, this event is recorded. So if you miss anything, you will find everything on our website soon after the event. Welcome again. My name is Maria Giuffrida from Trust IT. I am managing the communication and dissemination of Unlock CEI, who is the organizer of this event in cooperation with the other 7 projects that you'll see during the event. We have a very rich agenda this afternoon, so I'm just going to give you a very quick welcome, showing you the topics we'll discuss. Basically, we will start with an introduction on IoT in agriculture policies delivered by Doris Marquardt from the European Commission. Thanks, Doris, for being here. Our event is focused, of course, on cloud, edge, and IoT innovations in agriculture and crisis management, and we'll talk also about the relation with data spaces. So after Doris' introduction, we'll have some presentations from Unlock CEI representatives and from Agri-Data Space project. And then we'll have a full hour of presentations of relevant use cases by Meta operating system projects and by Agri-Data Space. We'll have also a moment to promote open calls, so funding opportunities for you if you're working in Cloud Edge and IoT. And then we'll close with a panel discussion with some of the speakers of today's event. We'll have also time at the end of the event for Q&A, but please don't limit yourself to asking questions at the end. Use every moment you want to animate the chat. Okay, our pleasure is if the chat is full with comments, questions, and even if you want to use it to present yourself and to network a little bit, we're happy that you do this. So we try to leverage on the networking effect, although this is an online event. So you can use the chat or the Q&A function, or if you want to speak, you raise your hand and we give you the floor. The session is recorded, as I said, and everything, the slides and the video will be available in the coming days. Thanks for listening to this introduction, and I now will leave the floor directly to Doris Marquardt from the European Commission for the presentation. Thank you very much, Doris. We cannot hear you, Doris.
Yes, can you see my screen?
Now, yes, now it works. Okay, perfect.
Good afternoon, everyone. First of all, thank you for the invitation to this webinar, to the organizers, but also to all contributing projects. I think it's very nice that you align efforts and that you organize yourself and organize the exchange of information. I'm Doris Marquardt from DG Connect Unit E4 IoT, and the unit is also focusing on 3 sectors: agriculture, energy, and mobility. So we are well placed here to accompany the webinar, and also best regards from my colleague Jan, which is policy officer and project officer for some of the projects. Thank you. So as we have a tough agenda and a straightforward agenda, I would like to use the opportunity to provide a brief overview and call the attention to some aspects and highlight why your work and the work of the project is important for the policy ambitions, and encourage you to consider some aspects in future, if not already done. So let's say if you have Horizon Europe or other European Union funding programs and have calls, it's mostly linked to the expectations that funding materialized and contributes to achieving policy ambitions. So in the field of agriculture, without going into detail, relevant, for instance, either a Green Deal, the digital age, but also better regulation and reducing administrative burdens, vibrant innovation ecosystems, or resilient and competitive agriculture sector and vibrant rural areas. So mostly you find it reflected if you have a call for, let's say, proposals, there is a link to policy ambitions. And one key message here is we strongly encourage you to demonstrate how projects at the end have the potential to contribute to policy ambitions, also at the end and not only at proposal stage. And for that, I will not go into detail of the policy cycle, but I would strongly encourage you to use the opportunity if you have project results, interim results, to seek, let's say, through the project or policy officers accompanying your project, to see the interlink and how far results are relevant for the policy cycle. We are not only looking and waiting for project results at the end of the project. Your support may already be helpful, for instance, post-studies, impact assessments, you name it. So we are looking for an active policy science interface and value your work. And you will see that interim results are also relevant to inform, for instance, future programming, because your lessons learned and your results matter. So, and one other message resulting from the slide, there's not only about policymakers and scientists, which we consider, let's say, in the innovation ecosystem, but also the end users in agriculture, the farmers, for instance, the industry and manufacturers along the supply chains. So meaning have a holistic view, and I think it's also already well reflected on, let's say, the stakeholders you invited to the webinar. And I think it will probably be a nice exchange, let's say, of views. Let's briefly reflect. I think most of you are familiar with Horizon Europe and the strategic plan for 21-24. So two messages are important for the, let's say, agenda today, which I would really like to recall. Under cluster 6, let's say, is a cluster where we focus, among others, on agriculture, more specifically, digitalization in agriculture, but also in food, is already high on the agenda. And you will probably know some of the projects already funded under the work program 21-22. You see in the left corner, without going into detail, there is a broad field already covered where we see potential of agriculture and digitalization through research and innovation being promoted. I would like that now currently we are in the implementation of the work program 23-24, and at the same time, and that is why I said the active, let's say, continuous exchange between projects and policymakers is important, we are already looking and planning the work program 25-26. So for us, it's quite important, what does work research and innovation-wise? What do we have achieved? Where are knowledge gaps? And maybe there are also challenges where research, let's say, was not successful, and we have to, let's say, have a closer look together at it. Do we need follow-up projects, for instance? And insofar, also the exchanges with the projects are quite relevant for us at the current stage. This, let's say, slide presents one overview. So the main ambition is to come from research to innovation and finally to deployment, meaning innovative solutions reach the end user, be it the farmer, the public administration, the food processor. So you have different target groups in your process, in your projects. You see here a lot of activities, and I cannot introduce within 10 minutes all of them. But if you are not familiar with those activities on this slide, I strongly encourage you to follow up on those, because the main ambition you see in the left corner, you see Horizon projects are an essential cornerstone for the innovation ecosystem, a starting point which can inform future innovation actions, for instance, under the European Digital Innovation Hubs, or they might be scaled up under testing and experimentation facilities for AI, or where you focus on contribute to the development or later also of the use of the agricultural data space. The Horizon Europe Partnership Agriculture of Data is forthcoming, but there, for instance, also a number of Horizon projects mailing up to inform the partnership and let's say the results of relevant projects in the field agriculture of data may be bundled and scaled up through the partnership as well. So I provide this slide as an invitation to have a closer look on you and see, okay, how your project fits into that picture and how the results may contribute to this overall innovation ecosystem and strategic programming, which we have as an interplay between Horizon Europe Cluster 4, Horizon Europe Cluster 6, and the Digital Europe program. And for sure, for the overall support of digitalization in agriculture, also other programs are relevant, like the Common Agricultural Policy, but we will not focus on that today. One main message is innovation, so developing the innovative solution is fine. So, but then we have to go one step further. So first of all, and that is mostly done already in Cluster 6 for Horizon Europe, we have to consider the specific socioeconomic and environmental condition, and in digitalization, what is also quite relevant for making innovative solutions scalable, the legal framing conditions, which are currently changing a lot in the field of digital and data technologies. So meaning innovation has to reach the end user. And otherwise, let's say it would not be effective as the solution. So meaning from the innovator side, be it a university, a startup, and so on, you are looking for having at the end for bringing the innovative solution to the market a sustainable business model. On the other side, if you look on the right-hand side, the end user ideally has the capacities to effectively use the innovative solutions. So ideally, the innovative process goes with feedback loops between end user and innovator. And on both sides, a lot of capacity building and networking is needed. Capacity building means, for instance, for the side of the innovators, they have to be familiar with legal conditions, socioeconomic conditions, and so on. The end user might have, let's say, the need for not only financial resources, but also the capacities to understand the abstract matters of data and digital technologies, or to gain trust. So that is an overall, let's say, simplified picture of the innovation ecosystem. So meaning, if we look at the interplay of innovator and innovative solutions and the end user, we know on the one side, digital solutions has the potential to strengthen the environmental and economic performance of the agriculture sector. On the other hand, we are well aware of that this potential is not fully exploited. And let's say researchers and startups have to consider the challenges and barriers in the agriculture domain, which may hamper the uptake of digital solutions. This is particularly relevant to cost effectiveness of some digital solutions, the trust in technologies, legal barriers, awareness of digital technologies, lack of digital skills, but also in some regions, a lack of infrastructure and services, for instance, broadband or repair services. So, and the overall question, which role can research and innovation play at the end, if it really comes to the end solution, in supporting policies ambitions, the digitalization agriculture and farm to fork ambitions? Apologies for that one. So, and here it's an essential role for you to play, namely research and innovation. And here I encourage you to consider the following aspects presented on the slides, meaning focus in your project. How can we increase the cost effectiveness on digital solution? How can we enhance the performance assessment opportunities? What are digital solutions actually delivering? So that is relevant for the farmers, that you can present with hard figures what is the benefit of a digital tool, but also relevant for policymakers when they decide should we support the investments into a digital tool. Developing technical solutions, facilitating trust and data sharing is in agriculture also a key component to be considered. And in addition, demonstration effects, for instance, through pilot projects, and that is why I also welcome the agenda today. I think that is very relevant in the agriculture sector to present the use cases, go out and show what they can deliver in practice and in feasible terms. then for sure, research and innovation should be need-driven and consider the development of business models and capacity building. And to some extent, the task of capacity building and business models we have already included for many projects in Cluster 6 of Horizon Europe. So let me conclude. We know most of the ISO in this webinar that digital solution can contribute to enhancing the performance of the agriculture sector and to contribute to achieve policy ambitions, particularly in the field of environment and the economy. It is essential to demonstrate the effects of digital tools and making them feasible, and also underpin them with hard figures for both the end user to convince them to invest into it or to take the step and learn about them, and also for policymakers to see, okay, what can digital tool actually deliver? So from our side, from the Commission side, we will say key instruments to promote innovation and innovative digital solutions in agriculture are already there at European level, Horizon Europe, Digital Europe, but also other tools, for instance, the Common Agriculture Policy. So what is now essential that, let's say, the innovation ecosystem and the actors in it, and you saw at the beginning, it's not only about scientists, end users, and policymakers, but the whole value chain has to use those tools in an effective manner and also consider the overall landscape of projects, initiatives out there, and to consider how they can potentially link up to the other initiatives, benefit them, or contribute to them. So for being effective, the instruments and the innovative solutions in their development need to consider the socioeconomic, environmental, and legal framing conditions. So and ideally, we manage then to achieve synergies, not only between the projects like today, which is great, but going one step further between research and innovation initiatives, programs, and also between countries as regards, for instance, use cases, or later in the implementation at deployment stage between different initiatives, for instance, regional data spaces. And you mentioned at the beginning, there is the opportunities to promote open calls. Also from our side, from the Commission side, we would like to call your attention that the call for the deployment action for the Common European Agriculture Data Space will open end of February until May, let's say 24. And with that, I would like to thank you, and I'm for sure also ready to address questions in the chat or later in the Q&A. Thank you.
Thank you very much, Doris. Virtual applause for you. I found your presentation pretty interesting, especially in the ecosystem overview and the final suggestions that you gave. I don't know if we have already any questions in the chat or in the Q&A. I don't see them immediately, but I think you can stay on a little bit more, right? So to address. Oh, I have someone who raised their hand, Marie. Marie, can you type your question in the chat if possible? Okay. And while we wait for the question to come, so we don't, stop the flow of presentations, I'd like to ask Golbu, welcome Golbu, to share your screen and give the overview of Unlock CEI. Thank you.
Thank you, Maria. And can you see my screen?
Yes.
Okay, perfect. Thanks a lot. Good afternoon, everyone. My name is Golbu Purabdollayan from IDC. I'm the coordinator of Unlock CEI project. And also from my side, welcome. Is a coordination support action, is one of the coordination support actions of the EU Cloud-Edge-IoT initiative. The other one is Open Continuum. Unlock CEI is mainly focused on the demand side of the computing continuum. And why, what is the context of the project and why the project is born? is based on the fact that we see that in the market, in the European market, the investment in the edge is increasing. So we see that by 2026, it's going to reach to $75 billion. However, still at the level of adoption, we see that the industrial stakeholders struggle to adopt the solutions on the computing continuum and struggle to do the paradigm shift. So the mission that Unlock CEI has is to do this deep dive into the market from different perspectives to the demand market of Cloud-Edge IoT, and provide support to the supply side and to research innovation actions in terms of identifying that what are the demand drivers, what are the value chain dynamics, what are the service requirements, what some insights about the market commercial feasibility, and what are the adoption levels of the use cases. So these insights in order to support them to bridge the gap between the supply and demand. We have a consortium of 6 partners, and we started our journey in June 2022. So very quickly, if you talk about the adoption of Cloud-Edge IoT in the agriculture sector, here you can see that the adoption of the 3 technological elements of the computing continuum in agriculture in Europe. So no surprise that we can see that cloud is just moving forward. So mainly the adoption is related to cloud. IoT and edge are not really that much currently, but the perspective is that they are going to increase in the future. These are the results that have been collected through the market research and the survey that we did in Unlock CEI with 700 interviews. And if we want to look at the agriculture sector in terms of adoption compared to the other sectors in Europe, here we can have a very interesting observation. Because as you can see here in the blue part, even though the current adoption of edge is in agriculture is not really high, actually it's low compared to other sectors such as manufacturing, such as energy. However, we can see in the green parts of the charts that the perspective is quite promising for the agriculture. So basically, 31% of the European players in agriculture expressed that in the next 2 years, they are planning to use edge solutions for agriculture. And this basically highlights the fact that even though now agriculture may seem that lags behind the other sectors in terms of the computing continuum and edge adoption, but the expectations and the forecast is that in the near future, it's going to recover the gap, and it's just accelerate quickly to reach this adoption level like the other sectors. And here, one interesting thing is that there will be the key role of the elements that also Doris mentioned in her presentation, such as the role of data spaces, because obviously adoption of these technologies is closely linked with the adoption and deployment of the data spaces. If you want to look at the drivers and benefits that basically pushes the agriculture players into adoption of the edge, the interesting observation that we have is that we can see that mainly the drivers are network related. So we can see that the main drivers for them are overcoming the unreliable connectivity, the very low cost latency, reducing the volume of data set across networks. And somehow it makes sense when you think about the agriculture use cases, because in the agriculture use cases, basically, we are talking about a wide area, not a focus area like manufacturing, for instance. And then talking about the use cases, we also did some analysis about what are the most adopted CI use cases in agriculture, and what are the ones that are being planned to be adopted in future. And here on the right, you can see the results. And as you can see, currently, it seems that all the use cases which are somehow related to precision farming, to farming 4.0, such as asset monitoring, such as visual inspection, for quality control, such as video security and surveillance, all of them are currently the ones that are more popular, let's say, in terms of the adoption. However, there are use cases that currently don't have a high level of adoption rate, But the expectation is that the forecast is that they're going to be adopted in a wide range in future. And for instance, one of them, which you can see at the bottom of the chart, is the autonomous vehicle, that the forecast is that in the near future, in the next 2 years, autonomous vehicles in the field of agriculture, with the facilitation of technologies such as 5G, 6G will be adopted much more in the agriculture sector. I really don't have much time, and I don't want to get other speakers' time, because I'm sure they have many interesting insights to share. Just to tell you that we have several reports which have been generated within the project. I invite everyone to check the website of EU Cloud-Edge-IoT, download the reports and read them, and hopefully you can find some interesting insights from there. So thank you very much. And Maria, I give the floor to you.
Thank you, Golbu. I copied the link also in the chat, and speakers coming after Golbu, if you want to use the chat to share other links to your initiatives, feel free to do that. Now it's time for Inessa. So Inessa, also from CEI, from VDI, to present dynamics, value chain dynamics in agriculture. So the floor is yours, Inessa. Welcome.
Thank you very much, Maria, and thank you very much for organizing this webinar. And so there is a strong connection between the Agri Data Space and Unlock CEI, and we're happy to host and invite the participants of the Agri Data Space also in our workshop, who provided valuable contribution to the project. And so I'll try to share my slides. I hope this is the right screen. So I hope you can see my screen.
Not yet, Inessa. If you
Not
want,
yet.
I can or maybe
one
now.
second. Yes. Now it works.
Yes.
So the purpose of Unlock Cloud-Edge-IoT is to fill the gap, to understand the demands and purchase decisions and criteria that are needed for further adoption of Cloud-Edge-IoT solutions. And we try to gain insights on market and commercial feasibility. And thanks to Golbu and RDC, we have a solid background that we can build on. And in our case, so our approach was to understand who is involved in a value chain, in a data-driven value chain, and to establish a dialogue with the key stakeholders of the value chains. And in the scope of Unlock CEI, we addressed 5 sectors, and one of these sectors is agriculture. And I think it was one of the most interesting ones. So how we proceed. So we had a first workshop wave where we discussed what were the major business drivers and what were the revenue flows and data flows in value chain networks, and where could be found vendor lock-ins or gaps, and also business opportunities. And so we come up with the following value chain, which involves, of course, also Cloud-Edge-IoT suppliers and machinery suppliers. We see here today John Deere. So there is also Class and some other machinery suppliers who are capturing and collecting the data on the crop fields. And so they are farmers and livestock players, and of course so they have their own associations, industry association, farmer associations, and there are lots of IT application and hardware providers, and of course different data sharing initiatives. We wanted to separate the term of data spaces and data sharing initiatives because they all are different. And food processing companies and suppliers, and at the end of the value chain are trade and retail companies. And the data floors address all the value chain. And we conducted in-depth interviews with major stakeholders of these value chain, and of course also with participants and partners from Agri-Data Space project. And as you can see, so we have so these arrows show value floor and data floor and information floor and goods floor. And we identified, for example, SCI technologies and software and specific actors with Cloud-Edge-IoT relevance, and of course actors that belong to the agricultural supply chain. And we see here we have to deal with hardware providers and infrastructure providers and data-driven service providers and machinery providers and vendors. So they're actually very are heavily involved in collecting the data and processing the data and understanding how they can make their machines better and how they can use the data for providing better services for the farmers. And we have here, we can see intermediaries. And for example, Ag Data Hub is one of such intermediaries. And we also identified, that will be one of the next slides, that there are lots of data sharing initiatives that already share and of course, we have already existing software for farm management, and of course, public authorities play a significant role regarding the quality and regulations that help all of us and make our food systems more sustainable and, of course, secure. So this is the overview that we generated to understand how the data flows, how the revenue flow, and which kind of information is exchanged between these different stakeholders. And of course, it is more interesting to understand. So you can see, so this is the slide from Agri-Data Space. You can see that data sharing already takes place, and data sharing, so we, our partners from ILVO found 440 initiatives and 140 initiatives that answered the surveys. Well, it's very much momentum that has to be leveraged in order to provide new services for the farmers, for the stakeholders, and to cover the whole value chain. So this is an overview about some example data sharing initiatives such as Eden, AgriRouter, and Ag Data Hub. I don't want to go into detail. I just want to mention that regarding their services and regarding so where the data is collected and stored, we find out that all these solutions are cloud-centric, which is well, cloud-centric in the sense that the big tech players, hyperscalers like Microsoft Azure and AWS and Google, so all these players participate and actually, well, they don't manage this data, but this is where the data is stored. And so if you look at the value chain, you can see that all the data is all the value chain will be covered, and all this data will be somehow centrally stored at cloud-based facilities. And it's a big question who will be in charge of this data. And so that is why I think the work of Agri-Data Space as a project is also very important to provide recommendations how to deal with infrastructures and how can we establish a fair data economy where all different stakeholders, farmers, machinery providers, IT providers, information management system providers, robotic solution providers, whatever, how they can share the data and how can they participate in data sharing, but still these data sharing economy remains transparent, neutral, and fair. So I think these are the last words I want to say. Thank you very much for your attention, and I'm happy to hear your questions.
Thank you very much, Inessa. As I said before, you can use this time to ask your question in the chat or Q&A box. Yeah, I see someone who raised their hand, but possibly it's better, I think, if you write the question. In the meantime, I'd like to leave the floor to Ziak Wolfert. Not sure if I'm pronouncing the name correctly. Welcome. I think you should have also some slides. So we now investigate the data space section more closely of this event with the presentation of Agri-Data Space project. So thank you for being here. The floor is yours.
Okay, I
Yes.
think you can see my slides.
We
Ready?
can, yes.
Okay. Well, thank you very much. Also, thanks to Inessa, who already introduced more or less a little bit the Agri-Data Space project. My name is Sjaak Wolfert. I'm from Wageningen Economic Research, and I'm the scientific coordinator of the Agri-Data Space project. Yeah, so before I dive into the project itself, I first want to give some background and some context. I'm not going into detail on this slide. Maybe you have seen it before. I presented it already in several other occasions. But maybe quickly, you see here a diagonal along two axes. The x-axis shows the IT integration level, ranging from standalone applications at the left to system of systems at the right. And at the y-axis, the more the organizational aspect of ICT and agri-food, ranging from a single process operator, which can, for example, be a farm or a farm worker or somebody else in the supply chain, towards complex business ecosystems. And you'll see here that you can, if you look at the diagonal, you see at the more technical side that you can speak of single apps and further integration into farm information systems, chain information systems. And then here, Inessa was already referring to the term, sometimes you can call them data platforms or data hubs. We call them an Agri-Data Space now, data sharing initiative. So yeah, you can always discuss about the complete definition, but let's call them data sharing initiatives. And above that, data spaces. So the idea, what I already want to introduce here is that these data spaces are a kind of integration, or maybe better, a federation of all these below lying systems. And at the right side, of course, you see the application where they have to be applied. Let's look at these data spaces. They should serve a food data economy and also more integrated food systems. And more importantly, I put over here that I think if we want to address sustainability challenges, we specifically have to focus in this area where data spaces will play an increasingly major role. Of course, you can have, for example, single apps that improve nitrogen use efficiency, so to address this sustainability issue. But we have learned that sustainability requires more integrated solutions where you can integrate all kind of different data. So in the end, when you talk about data spaces, not only agricultural data, but if there are also other data spaces, for example, from health or from the environment or mobility or energy, you can also combine more data to have a more integrated, sustainable solution for the sustainability challenges. And of course, as I try to indicate a little bit with this picture, IoT and edge systems somewhere also play a very important role in the whole development of creating these data sharing initiatives and also data spaces. Well, so far this picture, if you want to have more detailed background, I refer to the article, the paper that is here at the right, where you can go. So in the Agri-Data Space project, we look at these data sharing initiatives as being initiatives on the, let's say, the micro level. Ines already gave some examples. I will also show a little bit more. So most of them are targeting a specific sector, or for example, only targeting agricultural machinery companies. So that's the micro level, but the Common European Agricultural Data Space is more on the macro level. And as I already indicated, we consider it as a kind of federation of data sharing initiatives, as is also visualized here in this picture below. So this is another example of a DSI in a graphic way, the Ag-In scope. So you see here at the left, I think there are especially also the IoT devices playing a role. All kind of machinery and also the use of satellites and drones are being used to generate all kind of data to support management of the agricultural value chain. And through OEM platforms, they are integrated or federated in this peer-to-peer network. And at the right, you see more the application side, which can be farmers or farmers advisors. But you see also here, for example, representing the government or the administration that is also able to use these data. So this is what we mean by data sharing initiatives. And of course, it's always easy to draw this kind of pictures with all nice connections and lines. But yeah, the reality is, of course, very challenging to really deploy this in practice. So we picture a high-level architecture consisting of 3 different layers. So starting with the upper layer I just introduced, and you see here also some other names of possible examples of these data sharing initiatives. And they should use all kind of domain-specific software infrastructure, as you can see here, like Isobus, which is much more in the precision agriculture area, but also GS1, which is more into the supply chain, OGC with referring to all kind of geospatial data. So these are more domain-specific for agriculture, but they should also use the more generic infrastructure such as Gaia-X, Fireware, iShare, etc., which is, I think, still something for the future. So yeah, that is what we see as a high-level architecture. Ines was already showing this, so you can go to this interactive map where we mapped, and I counted this afternoon. We have now 454 data sharing initiatives identified, and of course, a lot of them are very immature or maybe just a kind of initial project. But yeah, this is the current status. And then the project itself is working towards a roadmap and different scenarios for this common European agricultural data space, looking at scenarios for governance. So what are the possible options for governing such a data space at the European level? So we are looking at the various opportunities for legal bodies, but also if they should have a membership model or other models. So that is what we are currently looking at. And actually, Inessa is also leading this task. So I refer also to her for more detailed information. At the same time, and what is very much related, is the business model. So what should be the business model of this common European agricultural data space in connection to all the data sharing initiatives? And we already said that we should avoid that this becomes a kind of Uber platform or a platform of platforms that's taking over all these data sharing initiatives. That won't work. So we believe that most of the business is taking place at the data sharing initiative level, but somehow also the common data space should have a stake in this whole business model. So we're also working on various scenarios for that. The same holds for the technical interoperability part. So referring to the architecture I just showed, we identified several mechanisms how we can work on this interoperability. So also there we have various building blocks identified and different scenarios for that. And finally, we are also looking at the ethical, legal and social aspects, also known as ELSA nowadays. So especially, of course, the influence or the context that is provided by the different acts, the Data Act, the Data Governance Act, and other acts that are coming up, but also at ethical questions, because data is also power. So how can we avoid power imbalances, or how can we make this common data space also in a fair and inclusive way? And therefore, we can also link up with many other projects that Doris was also referring to in Horizon Europe that are working on this topic. So this is the roadmap for the long term. So at the left, you see the current project, which is still, let's say, the exploratory stage. Doris referred to the call that is now open or will open at the end of the month for deployment of the roadmap. So that will be done over here. And then, on the longer term, we expect that there will be an operational common European data space. So that was in a brief the Agri Data Space project. So thank you.
Thank you, Jacques, very much. Again, if you have any questions, exploit this moment. Don't wait the end of the event. We are about to start now the use case presentations. We will focus now on the MetaOS, Meta Operating System projects that are part of EU Cloud-Edge-IoT cluster. We'll have all the 6 projects presenting, and also an overview of use cases that are followed by AgriData Space. So I'll start with Nebulos. We have 2 use cases from Nebulos. One will be presented by Vasilis Zaridis, and it's about precision agriculture. The other one will be presented by Amir Azimian on crisis management. That's also the other subtopic of today's event. Vasilis, please, you can start sharing the screen. Remember, you have max 7 minutes to present. And you can open the webcam and share your screen now. Okay, thank you.
Can you see my screen?
Yes.
Okay, thank you. Greetings to everyone. I'm Vasilis, representing Augmenta Precision Agriculture Technologies, which is a use case partner of Nebulous project. Nebulous is a meta operating system for brokering hyper-distributed application on cloud computing. Our vision for this project is to develop a meta operating system that seamlessly exploit edge and fog nodes in conjunction with multi-cloud resources to cope with requirements posed by low latency applications. Okay, a few words about Augmenta. Our company is located in Athens, Greece, and specializes in providing advanced automation solutions to farmers aimed at optimizing agricultural practices. Our innovative technologies are designed to reduce chemical usage while enabling farmers to maximize their yields and have an optimal management of their applications. It is worth noting that as of March of 2023, Augmenta became a member of CEI Industrial Group. Augmenta use case methodology refers to integration of cloud edge processing, reallocation of data streams to local resources, and sensor-based alert generation. The main goals are to optimize of resource usage for data collection and processing, to increase the management capabilities through platforms orchestrations, and of course data security through authentication processes. In this slide, you can see our main technologies. First, we have the Augmenta Field Analyzer, our cutting-edge device equipped with multi-spectrum cameras and advanced algorithms. This device scans plant health in real time and accurately calculates and applies the appropriate dosage of chemicals. Following the completion of a field operation, the gathered data is transmitted to the cloud for the post-processing phase. This phase yields essential insights, including farmers' application maps and reports on chemical and money savings. Lastly, all this information is accessible through a user-friendly cloud portal, empowering farmers to optimize their field management practices. Sorry. Okay. In our use case, our use case aims to leverage Nebulous to deliver more precise agronomical insights to every farmer following of the completion of each field of operation. This can be achieved through utilization of edge computing and intelligent resource management mechanisms. Yes, here you can see the integration of our use case, a diagram of our integration with Nebulous. After, let's say, a field operation completion, the gathered data transmitted to Nebulous through nearby 5G nodes. Then Nebulous, by utilizing its sophisticated mechanism, determines the optimal resource type required for efficient data processing, and then proceeds to deployment and the execution of the code that will produce the insights mentioned beforehand, and finally transfer the results to a cloud infrastructure. This process ensures that farmers can swiftly access comprehensive insights into their operations, facilitating them with the power of quick decision-making and enhancing the overall management. Okay, finally, the benefits of using Nebulous platform. will be very crucial for us. As a recap, Nebulous solution will provide optimal utilization of edge or cloud resources for each running task. A smart orchestration mechanism that will allocate and uses only the necessary resources each time. And of course, security and of course, high-speed data transmission, leveraging the 5G technologies. What do we expect after that? In summary, we aim to see significant savings in our cloud cost with utilization of edge computing. Plus, we expect a big reduction in processing time thanks to smarter resource management, which this means we can process more tasks in less time as well, boosting our overall productivity. And finally, in terms of actual numbers and KPIs, we expect a reduction of processing time about 30% with a baseline of 15%. And cloud cost reduction at 10% and decrease of processing capabilities at 10%. I think that's all from my side. Here are all the partners of Nebulous and some social media stuff. Thank you, everyone.
Thank you, Vasilis. I copied some of your links already in the chat. Also, Anna put some others. So if there's anything else you want to point the audience to, feel free to do that. We stay with Nebulous as well. So as I said, now we have the crisis management use case with Amir. Hello, Amir. Welcome. Feel free to share the screen right now so we go on with your use case. And again, feel free to ask questions in the chat.
Yeah, I hope you can see and hear me and my presentation well enough.
Yeah.
So I start, I'm representing the use case disaster management or crisis management by the Nebulous. I'm working, we are based, our organization is based on volunteer work, but due to this project, I'm working full-time, so to speak, as a research association. But in our team, I'm a planning and information management. So without any confusion, that was about me. About the organization, it's basically a network of the different let's say people, specialists in different fields, which tries and do so in two different specific category of disaster. One is wildland firefighting and the other one is urban search and rescue. Try to be more internationally deployed. And we have been the member of INSARAG. We've been classified in 2021 as the first line team, and we have also developed other units. About the theory, I try to be short enough. The crisis management, we have to understand usually in the early days or early hours of a crisis, we need a lot of information and we need a lot of processing. And usually because the infrastructure is already gone or hugely damaged, there is no capacity to be used. And therefore, our objective is to, let's say, bring our own calculation capacities to the field and also covering a bit of communication capacity with that calculation capacity or power, so to speak. The picture, as you see, it's actually recently or a year before in Turkey, which is obvious why we do need to take our calculation capacity with ourselves. Just to give you a better picture, Our slogan is usually says coordination saves lives. My, let's say, slogans add to that in this project. It's coordination needs information, information needs data, and data needs to be managed as well, which is, I think, obvious to all of you. Data need to be managed, and we have to make sense of data, especially in early stages, which a lot of unknown or unvalidated data is flooding to the, let's say, coordination cell. As I said, the infrastructure is usually not available or not functioning enough. The picture I love to share usually from the United Nations handbook for the UNDAC teams is we don't need to be super accurate about the data. We just need to be good enough in the early stages. Therefore, we come to the idea of bringing our own, and our question or requirement at the beginning of the project, which made a lot of, let's say, challenges for other partners. We wanted to be a standalone application and also be offline, which probably sounds here in this conversation a bit off the topic, but that's the reality we have to face. But I think this challenge also provides some benefits to other partners and also the applications itself. And we have experience and we have application which we already, let's say, developed it during the flooding in Germany in 2021. That map is still online, I believe, which we basically kind of visualize all the data which collected during our assessments to the map, which was online. Everyone could access it, and which was very beneficial. Come back to the application, the Nublus. Just to give you an overview, how would it be look like, let's say, if that's the application in between, we need to calculate this stuff, so to speak. And we have IoT sensors or devices to collect more valuable information during a disaster or in the early stages. And when the connectivity is there, we can also, let's say, add more data layer to it. Before anyone raise the questions, which always I face that questions, why we don't use satellite communication. First, it's probably not available. Second, maybe it's available, but it's not allowed. And third, sometimes it's forbidden. To your surprise, which unfortunately it's a good example, during the Germany flooding in July 2021, some nice picture from before and some picture from after. And this radio telescope, 100 meter, is that, I think, F-spec, is exactly located near to this flooding area, which if you, we don't want to advertise, but if you check with the providers map coverage, this area exactly is forbidden to get satellite communication. And with that said, we would enjoy these benefits, which we will see. We want to be offline as much as possible and stand alone. Let's say offline and standalone to start the application and the calculation capacity. And therefore, I called it, it's open conversations. Maybe we can call it a field cloud. I don't know. I'm not an expert on that field, but for now, we can call it a field cloud. It will enable us to start our computing even with small components, and we can scale it up as much as, let's say, other units or other calculation capacity will be added to the field. And therefore, when there is a connectivity, we can ramp it up to the clouds and access more calculations. Has to be light for us. Each kilogram costs a lot of money, especially during those early stages. That's from me, our partners, and the social medias, if anyone has a question.
Thank you, Amir. I think we have one question in the chat from Mario, who asks, why do you not see more benefits by introducing edge AI solutions? Such benefits could be reduced power consumption in the overall system, real-time application, increased security, efficient processing in the edge, and contribute to sustainability. I don't know if you have any comments on this observation.
If the question audience is me, I don't necessarily know what does mean edge AI solutions for crisis management, but I can assure you we have a lot of problems to, let's say, integrate any kind of solution to the existing system because of the data security, because of different organizations and many stakeholders which are usually involved. Therefore, they have different policies and you need all of them in early stages to collaborate. That's from me, so to speak.
Thank you, Amir. I don't know if anyone else has anything to add to this point raised in the chat. You can do so by you can answer, in the comment, or we can keep it in the panel as Andy suggests. So later in the event. I think now we can move on with the other project presentation. So we have ICOS, in particular Artur Jaworski from PSNC for agriculture operational robotic platform use case. Thank you, Artur.
Good afternoon. I hope my presentation is visible.
It is.
Yes, thank you. My name is Artur Jaworski. I work at the Internet of Things department in Poznań Supercomputing and Networking Center. Together with our partner, the Poznań Institute of Technology, in the ICOS project, we work on a use case which is named Agriculture Operational Robotic Platform, or AORP in short. Before diving into the use case itself, I'd like to briefly present the ICOS project. ICOS stands for IoT to Cloud Operating System. Its main goal is to create a meta operating system that heterogeneous IoT devices communicating through various communication protocols could use to create a coherent continuum architecture. ICOS strives at optimizing service execution as well as resources consumption. It addresses trust, security, and privacy issues, and tries to keep the integration costs as low as possible. So now let's see what really AORP is. AORP is an agricultural robot for use in wide row crops that performs field operations in an autonomous way. It performs precise operations of sowing, weeding, and spraying. It's powered by a combustion engine and uses central tool attachment system. On board, we have a powerful computer, as well as multiple sensors, cameras, which are used to provide all the data that is needed to both navigate the robot on the field, as well as collect information about the crop status. What are main goals of AORP? The main goal is to reduce farm operation costs by more effective use of resources. By performing precise operations, we mostly try to limit plant protection products, as they don't need to be used on the whole field, just in the places where they are needed. As a side goal, we try to promote and improve awareness of technological impact in the agricultural community. What really is the brain of the AORP? The onboard computer is being fed the data from the cameras, which is then analyzed by AI-based image recognition system. This system classifies all the plants it can see in the picture, and it can tell which one is a crop that we are growing and which one is a weed. When the weed is found on the field, it can then be extracted using a tool attached to a robot, or it can be sprayed using herbicide. This approach optimizes use of herbicides on the field, as it's only applied in the place where the weeds are, not on the whole field. Where do we see benefits from integrating with ICOS in our project? Which parts do we want to use? Well, first of all, ICOS simplifies deployment of software across all domains, which is cloud, edge, and IoT devices. Thanks to the fact that the data is accessible almost instantly, it reduces the decision-making latency. Thanks to the monitoring platform, we will increase the system availability. And by using the intelligence layer, we will try to improve our AI models so that they are more accurate and more robust. And last but not least, the coherent continuum infrastructure or architecture provides easy way of integrating new modules into the system when they are needed. And what are the key areas of AORP that we want to improve by using these whole modules that ICOS provide? First of all, we want to further develop the brains, which is the crop management analytics as a whole. We also want to add predictive maintenance of the machinery, which means that all the data coming from sensors mounted on the robot, on the engine, are fed into the AI models, which try to detect any anomalies to predict failures before they even happen, so that we can plan maintenance windows to replace worn parts and keep the downtime of the robots to minimum. We also want to improve robot operations, steering, navigating the field, obstacle avoidance, as well as develop farm and robot dashboards, which will enable the end user to have a quick glimpse at what is going on his farm, what's the status of the robot, if it's in mission, if it's available. And as a further work, we are considering performing field operations in the swarms, which means that a group of robots would be deployed on the field and work together to optimize the time taken to perform the operation that is needed. This concludes my presentation. Thank you for your attention, and if you have any questions, feel free to ask them.
Thank you. Thank you very much, Arthur. We did receive actually some questions in the Q&A box, which are, I think, more general for the panel. I saw Inessa already replied to the question in the chat, but I will copy again the question and the answer provided so far in the chat, so you can all contribute. to the general questions that some people in the audience asked, and then we can pick this up better later in the panel discussion part. Okay, so keep an eye on the chat. So I'll copy there the question that comes in. In the meantime, let's go on with the presentations. We are a little bit behind schedule, so please stick to the time. And now it's the turn of Nemo Antonios Gonos from Enersoft. Welcome. Hello.
Hello. Can you hear me?
Yes, I can hear you.
Can you see my
And
screen? I hope you do.
now, yes, thank you.
Okay. So, hello, good evening from me. I'm Antonis Gonos, I'm from Entersoft, and I'm here representing the NEMO project, Next Generation Meta Operating System. And I'm here to show you what we expect NEMO value will be in the smart farming trial. Okay. Okay, so what a few words about NEMO. Well, NEMO is main focus is transparent IoT to edge and to cloud continuum. It supports intent-based network and resource management. It's an open and modular meta OS, and it has the ability to provide end-to-end intelligence, advanced automation, and offer a massive artificial intelligence applications in the IoT. So in NEMO, we have two cases of agricultural interest, and they're both in organic olive groves. The groves are here in Greece. And the challenges in organic olive oil production. So the main challenge is to manage the olive fruit fly. It has a complex pest life cycle, and it's developed favorably in warm and wet conditions, and has very limited approved organic pest controls. And also the climate change effects. The effects of high temperature environment are genotype dependent, and the effect of the fruit fly is three ways. It affects the fruit weight, the oil concentration and oil quality in a cultivar dependent manner. So I'm sure you might hear in Greece is very interesting that lately we have a more than twofold increase in olive oil prices, and this is basically due to changes in the climate, and it has affected a lot of olive groves. So the smart farming use cases. We have two. One is about aerial precision biospraying in the farm. In this use case, we combine microclimate data that are collected by synfield devices from Synelixis, which are IoT nodes in the grove, and also combined with real-time video analysis of the olive groves from visual and multispectral cameras that are attached on semi-autonomous drones, and that are able to identify in real time where biospraying is needed. The biospraying decision is based on machine learning models which run on the end devices, while we also have increased model performance and increased energy efficiency through transferring the training process through with cybersecure federated deep reinforcement learning and deployment of the training jobs across the IoT, the edge, and the cloud resources using the NEMO platform. you can see here that the type of sensors and in the picture and information we can get from different sensors in the field. What are the benefits from using this? Well, we see that we are going to protect the olive trees from olive fruit fly through aerial spraying and targeted spraying, optimization of the use of biospraying without compromising the organic certification, and we are going to efficiently and responsibly use the resources that are available within the smart farm. In the second use case, we are similarly to the previous case, we are using autonomous robots equipped with cameras and sensors that collect data and locate weeds, and in this way are able to do optimal precision spraying with organic insecticide. The use case relies on machine learning models for the detection of the weeds, as well as for the autonomous movement of the robots within the grove. And it also detects potential obstacles like trees or humans which are present on the grove. The machine learning services run on the robot or at the edge on the cloud or on the cloud server of the smart farm, or even they can be moved to another farm if there is an energy efficiency automatically through the use of NEMO services. And this actually guarantees the high quality of service. In this use case, the expected benefits is the enhancement of precision biospraying with advanced multimodal machine learning models, which will lead to cost benefits for the farmer, both by increased and high quality production and the less use of insecticides. And we also have increased energy efficiency through flexible deployment of services through the IoT Edge and the Cloud Continuum, again using the services provided by NEMO. And finally, we have a reduction of CO2 emission just by moving operation closer to the edge or exploiting green energy availability. So what is the benefits of using NEMO in the smart farming application? So NEMO can manage the whole infrastructure. It provides us with openness, so we can use different infrastructure either close to in the IoT world, on the edge, on the cloud, or different clouds and different the availability of different farms, and make sure that this is optimized for a cost and it's also secure throughout the operation. We enable interoperability and end-to-end use of AI to manage all the data. And the end users, we hope, will be able to collaborate and have the best usefulness, the best experience. What we see as opportunities through NEMO for the smart farming is easy portability among infrastructure providers, democratizing the use of smart agricultural device, which means that we can share devices when we don't need them. We can transfer services through the devices for different use cases, enabling collaborative knowledge and knowledge creation among farmers and verticals, so we can finally share our models and be able to expand them, and facilitating data and intelligence sharing and exploitation, and in the future finally unlocking new business models for everyone, for the providers and the agriculture, the smart farms. Thank you for your attention. I think this is the partners involved in our NEMO project, and I'm open for some questions.
Thank you. Thank you very much, Antonius. As before, we keep an eye on the chat in case questions arrive. So we run them in parallel. And in the meantime, we go on with the IROS use case from Anna Riabocon from TT Control and TT Tech. If you can stop sharing the screen, Antonius, we leave Anna the floor.
I'm trying to find how to do that.
I think, Anna, you can just share
I can
yours.
see, I think I can, yeah, overrule a little bit. So I hope that
So-
it was functioning.
Indeed.
Can you see my slides? Can you hear me as well?
Yes, we can.
Good. First of all, thank you very much for the invitation. So pleasure for us and honor introduce here today in the webinar IROS project, and in particular use case we perform together with our partners. So I'm Anna Riabocon. I'm working for TT Tech Group, and in particular in IROS we are included with TT Control and TT Tech Computer Technique, so two companies. And we cooperate in this project with John Deere on the connected and cooperative machinery use case. And this case is generic enough. It could be also applied, for instance, to constructing machine, but considering this webinar, we will give you some insights on more farming side. And Alexander Wagner, colleague of mine from John Deere, will participate also in panel discussion. So I will introduce shortly the project, similar as other speakers did. I will give some details about the pilot and two scenarios we're considering. And I will give you some also analysis how we see the challenges considered in our use case can be solved with IROS solution, or the solution co-created with the project partner in the IROS project. And we will list some impact and benefits we see already now, but we are currently in deployment phase of this solution, and for sure in a little bit more time we can provide more details with this regard. So IROS is about data and also efficient compute and resource management. So it's the system or solution which provides, I would say, orchestrator on several layers like micro edge, far edge, and cloud. So it's very much about the operating system, about virtualization approaches, about pushing data between these layers to make production of, for us in farming domain, to achieve more efficient producing of plants, so yield we get from the use case outcome, such that the specific resources can be distributed within this system on several layers. So we consider, of course, data which we get from sensors, and we need to perform data processing and consider certain aspects like safety and security, for instance. And of course, similar to other projects, I see already some kind of synergies also with all projects presented today. So we consider deployment models and open standard. We need to deal with network management, but also, as I said, consider security and trust aspects. So sometimes you can imagine in the real life or real simulation as well, you need to perform certain operation closer to edge, because you can't spend resources. Also, you can't wait for certain decisions if you, for instance, access data through the cloud. This is the short summary of the use case we do. So in fact, or in short words, we try to optimize machine work to improve CO2 footprint. In first place, using electrical vehicles of John Deere, as you see here on the picture. And we perform semi-real-time data communication. You can imagine, for instance, the system should deal with different tasks. It could be, for instance, monitoring task during the driving, which is more critical, for instance, if you have to consider some borders on the field or similar, or other less critical tasks, like for instance, grouping or some different aspects. So we are two partners in this use case, and on the slide you see also very rough simplified diagram of the hardware infrastructure we use. So we connect sensors, we connect some displays, we do use GNSS receiver by John Deere for geotasks, and modem also for data routing and communication. But in the center of this picture you see also the device or platform which is developed by TT Control, which is here in the use case used for the high performance processing task. So we deploy a state-of-the-art strong system on chips to be able to process all data or huge data we get from the sensors. And all that is currently installed and also tested in the laboratory setup, but we are also in this next step placing this on the prototypical vehicle of John Deere. So basically the task is to perform large-scale agricultural tasks and enable communication between machines, collect data from different components, but also to synchronize and optimize this work of producing. In one of the use cases, we do it without AI-supported algorithms, but in the second use case, we also deploy some AI-supported methods to achieve certain optimization. So, and at the end, we need to show also improvement using real-time embedded analytics, so how we contribute also to sustainability aspects. This is the slide with short summary about the two use cases we consider. For both of them, the solution for TT Control will be deployed and tested. First scenario is about cooperative large-scale producing. What does it mean? So we, in first step, will integrate the platform and algorithms which we develop, and I will shortly mention them, for one vehicle, but also the intention here is to connect or to enable connectivity between several vehicles, so which will be tested here. So we need to perform field work in a platooning of electric vehicles. So the second use case scenario is focusing strongly on CO2 aspects to enable neutral CO2 operation, and here the focus is or goal is to reduce latency with real-time processing and reduce energy consumption. John Deere has some reference examples like a basis to compare, and within the project we are trying to improve that. This is the slide about, also very simplified slide about IROS architecture, which you see in the middle, shown in beige and also green color. So several services, basic services or some auxiliary services can be deployed on the platform. There is orchestrator or management system which should perform those services on the overall ecosystem. So in total in the project there are 5 use cases, one like production or port use case. So we are focusing John Deere and TT Control exclusively on farming use case. On the top of the slide you see the infrastructure components. So this is vehicle I mentioned, and also high performance computing platform, but this is also we deploy or use on-premise center provided by John Deere, and also with this cloud, this is a presentation of operational center of John Deere. So with certain data already, historical data available in place for the comparison, for instance, within the use case. On the bottom, I mentioned sensors. We, for instance, enable driving and also autonomous operation. We rely, for instance, on CAN bus interface. Some who work more in automotive or off-highway application know why this is needed. So this is to enable vehicle to operate in safe manner and execute communication tasks. But we need also to have a vehicle control interface. And in red, you see 5 application examples which are used in the project for both use cases or for one of them, which are partially developed in the project, but also adapted by the John Deere specifically for the needs of the project. For instance, this is machine analysis AI engine, or tillage adaptation, or tracking and navigation application. This slide is the short summary for sure Aero solution, so which I said co-created in the project can provide much stronger capabilities and much more services available for several applications. But for us, we see benefit of this solution for three main things. So this is for distributed edge computing intelligence, for decentralized intelligent using AI, and embedded analytics. So tractor should operate in a robust manner, so we can assume that there is no connectivity. So you can imagine that we should take care of these aspects. And so there are strong challenges on communication part, but we still use also embedded analytics supported by operational center of John Deere for improved operation as well. Services should be orchestrated similar to other projects mentioned already, and we need to ensure balance of our resources between different layers. So this is all we do, of course, in present. So the huge amount of data available for the processing, and yes, as I said, we mentioned here only three benefits, but for sure there are much more which project provides to the community. Shortly about DT control, just few words. You can read also my slides later. So we are expert on mobile machinery operation electronics for several domains like construction, agriculture, material handling, but also special vehicles like, for instance, snow groomers. And for all those applications, we deliver either electronic control units, or for instance, human-machine interface displays, etc. But we also support our customers for the application development if cloud services should be included. We have several business units, but Aeros is only relevant for TT Control, which is joint venture of TT Tech and Hydak International. John Deere, our partner in Kaiserslautern, it's our European Technology and Innovation Center in Germany, with about 250 employees there, with a very strong cooperation with university and research institution, and with the focus of intelligent system for precision farming and other technologies related for these tasks. Worldwide, John Deere has more than 82,000 of employees, and this is the shortly portfolio and images. I think this is a great examples to see, understand what this company is doing. So they are producers of agricultural equipment, on construction equipment, but also on the tools, for instance, and yeah, some other solutions. I don't want to take more time. I will post in chat the link to the website of Aeros. Please have a look. We have a lot of also public deliverables which describe in detail use cases. And as mentioned, Alexander and myself are available also today for questions. Thank you very much.
Thank you. Thank you very much, Anna. So just a recap on where we stand in our schedule. We have 3 use case presentation missing, and then a short overview of the open calls, and then a discussion, and we have 40 minutes left. So we are basically running a little bit late. It's fine, because we gave more time to questions in the chat and to use case presentations, but now I really need to ask presenters cooperation in sticking to the time. So for Andy, Leonardo, and Roberto, try to not exceed 7 or even 6 if you can manage minutes. Okay, so maybe then you also participate in the panel discussion, and so you have time to elaborate better, on something else. Let's start with Andy. So Fluidos project. Andy, you can share your screen and present the viticulture use case. Thank you.
Sure thing. So very quickly, I'm Andy Edmonds. I'm CTO of TerraView. We're providing the smart viticulture use case inside of Fluidos. I'm going to do things backwards. I like to do things backwards. So that's the company. The company has progressed itself up to now, and we're about 20 people here in Switzerland, and we got 32 customers, all predominantly viticultural customers, but there are cases of olives and such. If I jump on to my next slide. So just on the product itself, and the reason I bring up the product itself is because it's this product that we're actually bringing to the edge. And so people need to understand what the various workloads are there that we could potentially consider. So here's the typical thing of, yes, we've got satellite, brilliant. Yes, we've got drones, and drones indeed, if you look at the payload of a drone survey, it's typically about 100 gigabytes. And currently today, that's uploaded up over the network. We don't want that. And so we're going to pursue that in terms of the framework that Fluidos provides. There's further integration of data. This tends to be binary or text type. The magnitude of that data is a little bit less. However, we integrate with many other things, including robotic integration from a green culture and soon with a green robotic. We also then, of course, we have to manage what's happening on the ground. And so, for example, we have alerts and recommendations that are generated based on all the information we receive. And that's also further elaborated and enhanced upon by machine learning models that we have in execution. What happens on the ground is very important. Naturally, we have ground workers there working. We have the application of chemicals, nutrients, etc. So these need to be tracked. The activities are not just anymore human, but they're also robotic. And so therefore we have on the ground, and also we have drone automations included in the platform. And along with that, soon to come along is the life cycle assessments, which allows us to understand the carbon impact upon the ground. One of the key things here for us is mobile applications. Farmers, ground workers, they do not have laptops. They do not sit at a desk. They need the information to hand. And so what they do is they can use our tools to run around the vineyards and understand what diseases or nutrition problems that they have, and that's reported into the central dashboard. Very important is yield estimation, also prediction. This allows for farmers to understand what sort of capacities that they need when it comes to harvest time, and also understand what contractual obligations will be reached and potentially missed. If they understand that something is going to be missed, then they can make various measures to avoid this. Now, it's slightly to a side, but still on the whole aspect of impact on water, on agriculture, we have AquaView. AquaView was something that we came up with. We understood the case that, yes, indeed, 70% of water is used for irrigation and agricultural purposes, but of that 70%, 90% is wasted. So we're tackling the UN SDGs in order to arrive at a solution that's a sensor-less soil moisture mapping analysis. There's a lot of advantages to it, but the key one here, apart from cost and automation, is a plus or minus 1.5% accuracy compared to the ground truth that's obtained from the hardware. That use case is actually, well, it is a use case also in two projects, TEDL and EXA for Mind. TEDL is one on data spaces because we do generate quite an amount of data here. As I said, we want plenty of impact from the perspective of certainly AquaView. We launched this for free, and we want to be able to minimize water wastage in agriculture globally. So that's available right now for people to use. All about the cloud continuum, there's a lot of focus on computation. However, it's the data that really makes the difference here and matters. And from our side, we've got plenty of data itself, and it's exercised in quite a number of the projects, and indeed in Fluidos, one of the places where we do this. So if we jump across now into Fluidos and the reason why we're all here today, from our perspective in Fluidos, we currently see that there's a silo-based computing continuum, okay? It's very difficult at times to manage an application from the far edge, even the small device, all the way into the cloud. And so it's this particular challenge that we're tackling inside of Fluidos. In Fluidos, what we have is another Meta OS, and yes, there are plenty of them. And so we have to be very careful in distinguishing and delineating ourselves between everything else. But what we see is that from within Fluidos, we allow for the to deal with multiple technical administrative domains and boundaries in order to provide transparent deployments, the communication and resource availability. And that's essentially a management plane and fabric that we have inside of Fluidos. So from a perspective of the smart viticulture, Fluidos and TerraView, we've looked at it and we've seen that the current approach that would be there is that there's no simpler integrated fabric over the cloud continuum from our perspective. And there's no easy way to define in terms of, KPIs, non-functional properties, etc., to manage that application. And they're, of course, very important, especially for our end users, is security, privacy, and trust. Trust is something that is born out of that, having that security and privacy. And so our expected advantages from Fluidos in the case of our particular use case is to have further business continuity. So we talked about, indeed, lossy networks and such things like that. The network between the core and the actual edge isn't such a big problem. You need synchronization between them, and that's what we're investigating in this use case. From security, that's very important. So they're looking at trusted execution environments, and from decentralization, has a two-phase approach as such. One, from decentralizing, it means that there's less load on the central resources, so there's a knock-on effect and a positive one for ourselves in TerraView. And from the end user side, there's more control, more privacy, and understanding that they can do the processing there, and so therefore avoid the large ingress charges. And indeed, the time to get the data up there to do the work. So from our side, this is the scenario. The scenario is a rather simple one, but it can be, and it's the scalable one. It's one that we can grow. Here, what we have here is the TerraView OS itself in the central cloud. And at the moment, we've got 3 vineyards, all of those having edge devices. What we want to be able to do, and what we're investigating and what we're working upon now through the implementation of our use cases, such that the edge users, so here we have 3 of them, they all have particular computation loads dedicated to them. However, some of them are, if you want to call them, virtual. These are ones that are executed yet accessible within the core cloud, and that is made available by the Fluidos framework itself. Nonetheless, if you're a non-edge user, you can still use and access the facilities of an edge user. So in the case I'm an edge user C1, I can access that information from anywhere. So we're doing stuff. So here you can see there's 3 devices. These are edge devices. All these edge devices have Fluidos upon it. They have particular pieces of functionality of TerraView OS on it. The key piece here is actually for image processing. So we will run the image processing as the first workload out on the edge to avoid that large ingestion of data. And here you'll also see that the user interface is running there locally as well. So that work continues, and where we're looking at it for the next, let's say, target platform will be the integration of the drones and the robotics, they being smaller devices yet again that will be operating within the vineyard itself, but yet controlled by the local edge resource itself. That brings me to the end of my presentation, and I hope it wasn't too long. Any questions, you can grab me either at the panel or in chat. So thanks for your time.
Yeah, thank you very much, Andy. I forgot to unmute myself. Now it's Leonardo's turn. So from Nefele project. Yes, I see you there. Hello.
Perfect.
Hi. Please share your screen so we can start and try not to.
I'll try to be short.
Yeah, thanks.
Yeah, so hello everybody, I'm Leonardo Militant from the University of Zurich in Switzerland as a partner of Nefele project. Just a couple of words about the vision of Nefele. It's a MetaOS project that tries to build a system for a reliable and secure end-to-end orchestration of distributed applications over the continuum from the cloud to the edge to the IoT. And to overcome all the barriers and interoperability barriers for IoT devices. So this project tries to cope with these issues with two main innovations. One is on the side of IoT to build a BioStack that enables the interoperability between IoT devices, and the other side, the orchestration through the whole continuum. So we are involved in many aspects of the project as a university, but in one particular case, use case, we are involved for emergency and disaster recovery. So it's nothing to do with agriculture, but it's more about crisis management. The partners are mainly two partners, IRIA, which is a research center in France, and us. And what we want to build is a system or a demonstration of the capability of Nephle to support these kind of use cases and the specific of disaster scenario. We try to enhance the situational awareness of first responders, in this, for example, firefighters, and to collect the data so that they can prioritize their rescue operations. What we need to do, in these use cases, to deploy an infrastructure that is able to collect the data. We need to improve the situational awareness of the first responders, and also enable some kind of detection of the risk and of the victims in the area, to make mappings of the area and provide assistance to the victims. So we have an example scenario here. This is a Luka Koper. It's another partner in the project. It's a Luka Koper container port in Slovenia, where we are simulating, emulating, and then demonstrating our use case. We imagine that we reach this area and there is no networking. There is you cannot rely on the mapping of the port because some storm occurred or an earthquake, and there we need to take actions using some devices which can range from ground robots to drones and wireless sensor networks. So we need to deploy this in an efficient way, and then deploy the application that runs the whole use case through Nephle. So we'll use ground robots to map the environment. We'll use wireless sensor networks to sense the environment, and then of course cameras and computer vision to detect the situation and map possible risk areas or detect victims in the environment. There are some, of course, a lot of challenges in this situation, because there is an area that we don't know. There is a connectivity probably is lost. There is a high number of heterogeneous IoT devices that are on the area that produce their data. There are different quality of service requirements from the devices and for the specific application domains. And we need for probably the edge to have low delays in computing some heavy load computations. And of course, the whole situation is dynamic, so with this will have to change over time. So we have to deal also with this. The idea is that we do some mapping, as I said, of different application domains, application scenarios. So mapping of the area, victim detections, risk prediction, device deployment of wireless sensor networks. So the idea is that we use ground robots to deploy a wireless sensor network, and then we have also to monitor the whole system. And all of this is supported by the Nephle ecosystem, which orchestrates the application, the hyperly distributed application, and over the cloud, over the edge, and the IoT devices, and using an abstraction as the virtual object stack proposes in the project. So the added values from the project for our use case is that we have a reduction in the computational loads on the robots, which I have not a huge amount of computational power, so that we can do heavy load computation on the edge. For instance, we can generate collaborative solutions for mapping the area using drones and robots. We can identify objects, victims in an area using AI models that can be run in the cloud or in the edge and not necessarily on the IoT devices. And by this, we will improve the situational awareness for first responders, for mission control and optimization of the tasks. Here you see briefly the consortium. It's for the Nephle project, and that's all. I hope I was fast enough. Thank you.
Thank you. Thank you very much, Leonardo, for your presentation. It was clear and efficient. So many thanks for your flexibility. And now we have the final use case presentation. before open calls and quick discussion. So Roberto Garcia Gonzalez from, again, the Agri-Data Space project.
Okay, thank you. I will.
Yeah, if you can, again, be efficient with time, we'd appreciate that. Thanks.
Okay, I think you already see my screen. So basically, I will try to be very, very fast. Basically, this is not actually a use case from Agri-Data Space because there are not use cases in Agri-Data Space. It's more about setting the roadmap towards the agricultural data space at the European level. But basically, in this slot, what we want to present is some experimentations that we have done that are connected with our work in Agri-Data Space, but also other projects where we are exploring going beyond trying to implement some of these views from data spaces. And we thought it might be useful because it's quite connected in many senses also with compute in the edge and all these things that are being dealt in this session. So basically, what I wanted to highlight is one of the main motivations of data spaces is to lower the barriers for data sharing by increasing trust on the participants, on the stakeholders. And one of the mechanisms used or proposed is that of data sovereignty. That's basically to put the owners of that data in control so they can decide what is done with their data and also get a fair compensation for their data. And this sovereignty is not at just the level of states or organizations, but we can even see that at the level of individuals. We think that this mechanism is very important as a building block to later maybe monetize, tokenize data sharing in order to build incentives. But it requires to some extent that this not losing control on the data is a reality, no? That is actually true. And the paradigms that we put here in order to better understand what we mean or what might be the extreme case about control is that what happens in digital music, because anything that is digitalized is then very easy to copy and disseminate. So it's very difficult to remain on control on the data once you share it. In the context of music, we have seen that there are alternatives like the digital rights management that didn't work quite well because enforcing these reuse policies, in this case of music, but also on data is very difficult, especially if you are outside a controlled environment. For music, the solution, or pretty much what they came to, is streaming. It's a way of avoiding or making it more difficult to copy, so it's still possible. And we want to explore also for enabling this data sovereignty, let's say by design, that the systems provide that control to the users, what alternatives they are. We have explored solutions based on what are called the connectors in the context of data spaces, that are basically peer-to-peer connectors that enable the transmission of the data from one end to the other. But so there are some mechanisms like policies governing what is done with the data once it is sent to the other end of the connector. There is a lot of difficulties of enforcing that use of the data, because once it is copied, you lose track of what is being done, especially in environments that are not with some level of trust at the beginning, just like with DRM. So we're exploring the concept of data rooms and compute to data. And basically, it's a way that we're exploring to provide this data self-sovereignty by design, in the sense that we have all computation happening or the processing of the data in one room. You control who enters. In this case, it will be an algorithm, thinking about compute to data. You also control what leaves the room. So using this idea of data room to guarantee that you don't lose the control by someone getting a copy of the data or a subset of it, just aggregations that don't include personal data, for instance, or train models that guarantee that level of control of the original data, that you cannot replicate the data from the trained model. So we have been exploring that. There are some solutions in the context of initiatives like Gaia-X to provide this kind of mechanisms. There are already implementations doing that. We have been experimenting with it, with this idea of keeping the control on the data. It combines compute to data. Also, we can increase the level of control with trust execution environments, and also blockchain and self-sovereign identity for all the other matters more related with ownership, transparency, also monetization, tokenization, and so on. So we have a proof of concept as a small portal where we have some of these solutions already running for a very specific, in this case, use case, let's say. One of these is in the context of the AI for pork use case. We have an experimental pig farm with different kinds of sensors. And the idea is that we can use this approach, compute to data. In this case, it's at the level we are providing this service to this farm. The idea is that we can, as a more trusted party, guarantee that you can go reuse, train, process the data, but without living with copies of the data from this experimental farm. And one example that we have implemented is for images of a pig pen. And the idea is that the farm doesn't want these images to be leaked outside. So basically, it's an algorithm that you can send to this data room, combine it with the pictures of the animals in the pen, and then compute some metrics related with well-being assessment. And the algorithm just comes out with these metrics and doesn't leak any kind of image. And moreover, we have added monetization of the data. You can pay for the data, for the algorithm, and also for the computation time. So we are also exploring other topics, like also doing this in these data rooms, all the process of integration, semantic integration of the data, and also pooling of this data, so also guaranteeing control. And we are also experimenting in moving these data rooms to embedded devices. So we can see, for instance, they added to machinery, so that we can send, apart from the cloud solutions by the manufacturer or whatever, we can also explore options like when there is a lack of trust or you want to keep this control on the data, that you can also use this embedded data room to send algorithms, compute just the metrics or the reports that you need, and leave the original data on the device without leaking any information. And that's also another case that is more connected with compute to edge. And that's all. I tried to be really fast. I hope it was fast enough.
Yes, yes. Thank you very much, Roberto. And thanks to all the presentations. I agree with George's comment. Very nice use cases with everyone. So virtual applause to every one of you. And now, before moving to the final, let's say, discussion with some of you, let's hear some funding opportunities. So the open call from Nebulos and from Fluidos. So let's start with Nebulos. Anna, in very short minutes, please tell us more about Nebulos open call.
Yes, absolutely. Hello, everyone. Good afternoon. So, can you see my screen?
Yes.
Yes, fantastic. All right, just quickly passing by to let you know about this open call one that we just launched last week on 14th of February. The open call will be open until 17th of April, and the main call objective is to validate the basic aspects of the platform by showcasing new use cases different from the domains already tackled by the project. And the team has established 4 different challenges that we invite you to apply for. You have the first one focused on the workflow application, a second one focusing the IoT application with variability, and the third on serverless application. We leave a fourth open challenge for anyone that can, if you don't find your project in any of the other challenges, please submit via the open challenge. More to say, we have available for this first open call 600K to fund 4 projects. It will be 100 up to 150K equity free funding for those 4 projects to run 7 program for 7 months. The eligible applicants are the industry, SME startups working in the field, as well as research organizations when applying in a team of 2 organizations, knowing that the lead partner should be an SME. The applications are handled via the F6S platform. We invite you to have a look at the platform and also to read the guidelines and all the documents linked with the open call 1 in the website of Nebulous. Quickly mentioning that on the 5th of March, we will have a webinar to answer your questions, all dedicated to the Open Code 1. Of course, we will have our pool of experts. Mostly the technical partners will be able to address your particular questions. And also I will be attending this webinar to clarify any administrative question you might have. And that's all. Thank you very much.
Thank you very much, Anna. And now we have Costanza Pestarino for Fluidos.
Yes. Can you see my screen?
Yes, not in presentation yet.
Voila.
Okay.
Can you see it better now? Yeah. Thank you very much for this opportunity. I will try to be very quick, as my colleague before. So I'm going to talk briefly about Fluidos Open Codes. Briefly, thanks to this project offers 2 kinds of grants: the technological extension grants and the use case grants. The first kind of grants will be open for individual applicants. This means startups, SMEs, simply one entity. And these grants, these kind of grants will be open for applicants who will receive up to 75,000 euros in financial support in order to develop and integrate open source functionalities on Fluidos projects, while the use case grants will be open both for individuals and for small consortia. This means maximum 3 entities, among which one has to be an SME. These kind of grants will be up 120,000 euros in financial support, and the main goal of these kind of grants is to validate Fluidos architecture and exploring new sectors. The first Fluidos Open Call is open, was launched in December, and will be closed in indicated 19th of February, which is today, but it will be closed at the end of February. This is just to highlight that there are 10 days missing. I inserted more slides, but this is the last I'm going to present because I think it's very important. Thanks to this project and these open calls, there will be Fluidos champions. Who is a Fluidos champions? Well, when you're going to send, if interest, an application to take part to or win one of the 2 grants, there are Fluidos champions, which are partners inside the project. They are more than happy to support you in your application, review your draft application, and give you constructive feedbacks prior to your submission. This is a tool that can help all the interest applications, but since the project is going to, since the first open call is going to conclude on the 29th of February, in case, please contact us to have a Fluidos champions to support you by the 22nd of February, end of business. Said these, just briefly, there will be other slides in this deck that will be shared after, with additional information about the application process, evaluation process, and grant process. And the links to have more information on the guidelines for applicants, the white paper on Fluidus architecture, and an email where you can write to us all the questions and queries you have. So again, I stop sharing. Yes, Fluidus Open, the first Fluidus Open Call. A second one will be held in August, but the first one will end at the end of the month. So please go and check these opportunities. Thanks.
Thank you very much, Costanza. And now let's move to the end of the event. We have basically 10 minutes left, so we have to rearrange a little bit, let's say, the timing of this panel. I hope my panelists will be flexible enough. So who will be commenting, let's say, the event with me in these last 10 minutes are Leonardo Militano, who we already met in the presentation of the use case from Nefele. Then we have Andy as well, right? Should be available. And then we have two new speakers, Konstantinos Railis from Synelixis and Alexander Wagner from Jindir, connected to Iros. So Andy's back. Let me maybe put you more in a visible way. So what I would like to talk about now is basically take inspiration from the comments that we had in the chat and basically start asking you one question, 2 minutes each to reply. That's focused on sharing with us if you have any, let's say, lessons learned or best practices from your experience in both academia or industry, because you're representing different worlds, that could be taken as an example for the successful implementation of Cloud-Edge-IoT technologies in agriculture, but also beyond. And especially in your examples or best practices and lessons learned, if you have any considerations that go beyond the technical perspective, just to address the comments we read now in the chat, so related to inclusion, broader inclusion of stakeholders, multidisciplinary approach, and a larger perspective that's not only technical, please also share this type of examples so we address these topics a little bit. Okay, so maybe let's start with Konstantinos and Alexander, who we didn't hear before. If you can let us know on your experience, any lessons learned and best practices for use case implementations. So let's start with Konstantinos.
Hello, can you hear me?
Yes.
Okay. Well, I'm Konstantinos Railis. I work as a software engineer at Synelixis Solutions, which is a company that participates in the NEM project, as well as the coordinator of the Agri-Data Value project, which is pretty much related to, in a way, to Agri-Data space that was presented earlier in a manner. We have a precision agriculture solution for farmers that allows them to monitor the conditions of in their field and to perform and control actuators, for instance, for irrigation or for opening and closing a window in a greenhouse. So pretty much our experience comes from this respect. I really enjoyed the presentations generally and the use cases. What I would like to basically say is that from our experience, both from our product and within the Agri-Data Value project, which includes multiple, more than 20 pilots with actual farmers, let's say, is that I believe a good amount, basically, there's a bit of a skepticism from the farmer side generally to the adoption of technologies. Not only we're not talking only about cloud native or edge computing. It's generally, especially in Greece, they're a bit skeptic about the adoption. So what we have found out to maybe be a bit effective is to actually sit down with the farmer, discuss their actual needs. This is something that we do in our experience through Synelixis and also within the project, within the AgriData Value. And we have found this to be actually a bit productive. Yeah, that if I had the suggestion to make is to really communicate with the farmers what they can get. Really try to form solutions that they can understand. Yeah, I believe that this will lead to really try to communicate the benefits, and this will lead actually to wider adoption of smart farming solutions. Generally, I don't not only cloud native, but generally.
Okay.
Yeah.
Thanks, Konstantinos. I think that's very, reasonable advice.
Thank you.
And what about anything that you can add, Alexander, to this?
So hello, I'm Alexander. I'm working at John Deere here in the European Technology Innovation Center, and I'm part in the IROS project. And we at John Deere, you saw it before in the presentation, which were well, thank you for all the presentations. And in our presentation, we showed that John Deere has a quite big portfolio of machines for agriculture business, but also construction and forestry. And what we learned from our customers, farmers especially, they are, as said before, they are skeptical about technology or the data-driven technology here, or the adoption of new tech. And yeah, what we get as a feedback from them, or from our as a solution for this, was that we had some, for example, first adopter farms where we could first present these new technologies, so we could show how they work, how they operate, and therefore they could also see some benefits from this technology, and also got an idea what are the improvements also from an economical side over not only 1 year or some years. So they can plan better, because farmers normally have high pressure, economical pressure to operate very efficiently. And if we can show them that there are improvements by these new technologies, or the implementation from different cloud technologies, edge technologies, then they are more open to adopt this new technology.
Thanks, Alexander. In the meantime, for those who are still connected, I'm copying the question that I've asked you also in the chat. I repeat it for Leonardo and Andy. So just as a conclusion of the event, what are the best practices that you can share in terms of application of use cases, not only technological, but also broader considerations? We've heard from Konstantinos and Alexander the importance of involving the farmers and the end users. Leonardo, you're representing a university, so any considerations from your perspective on this?
Yes, thank you. I have mainly two. One is that from a university perspective, we love doing fancy things, right? Doing research on the last technologies and trying out things that we never saw before, and then we feel happy for that. But companies have another perspective on this. They need an impact on their business, so they usually are looking for a product that they can sell, or at least it can be useful. And these two worlds sometimes they come from different sides, but look at two sides of the same coin. So they both want to use technology, but they have different points of view. So there you have to find a point of contact, of course, and also an agreement on, okay, research is fun, but let's also do something real, some real product. This is one aspect I think is important in the collaboration between universities and companies. The other aspect is a bit, I share what Alexander Konstantinos mentioned. He's talking to the end users, especially. In our use case, for instance, we're doing a use case on emergency scenarios, and there we talked, for instance, to several firefighters brigades over Europe to see what they really need, and they say yes, technology is good. But there is a bit of skepticism also for this technology, because especially for emergency scenarios, it's also related to a bit of a risk, personal risk. So they really need to trust the technology to use it in their operations. So there you really need to sit down, as somebody said before me, and explain how the technology works and build a bit of confidence in the technology itself. And on the other side, also really understand what the needs are. Again, back to the research aspect, we would love to have the most fancy research thing, but they have real problems that they want to solve. So we have to talk together and talk to the end users for this.
Thank you, Leonardo. And then Andy to conclude.
Okay.
Okay.
Yeah, no. I've got a couple of ideas. All right, wait now. So certainly, I absolutely agree with the idea of. I always get in trouble when I call them farmers. Okay, they're landholders, and they have many of them have significant resources, and all of them don't have a lot of time. I don't mean that as the death sentence or something. They've got 40 attempts to get it right. And damn right, they should be skeptical about anything that comes in. And somebody says, I'm going to fix it all by having all your storage on site. That's a bit of a head scratcher for somebody who's concerned with growing the best produce possible. And that is bound not by the speed of an electron or the speed of light in that case, but bound by the simple natural laws of Mother Nature. So whereas we'll come in and we'll say, oh, you'll be able to do it really fast and and all of this type of thing, it's not really a concern so much for the landowner, for the property owner. And also, where it starts to matter is not with the landowner, it's actually when you move up and not consider things from a business to consumer perspective, but you look at it from a business to business. And this is what we do in TerraView. We will, our typical customer will be an enterprise type user, and they will then manage large amounts of property. I'll give one, for example, is Treasury Wine Estates in Australia. They've got 12,000 hectares. They delegate and they work down upon these people. And they need to be able to understand their assets, their investments, and how they're actually coming along, especially with ESG aspects, and that's why we also have AquaView there. And the point there is that these are the target audiences for ourselves at the moment, and we're there with them because that's where we can make the most impact. But certainly when it comes to those that own land, education is needed, simplification is needed, here's one thing that I always say: the presentation of tools to help with regulation are super important. So we've seen plenty of farmer protests in recent times, and a lot of the time it's boiled down to unreasonable regulation being forced down from authorities. And the farmer has no real handle on how to actually deal with that. A typical one might be nitrates. So how many farmers out there have nitrate sensors? Not many. So it's these type of things, and it's not the technology necessarily. It's not like 5G. I can tell you 5G is not really needed. 4G is perfectly acceptable, even 3G, especially if you've got synchronization protocols there. And
and so that's my take. So really, what you tend not to see so much is the inclusion of social sciences and humanities in all of this, and they're needed in order to then further drive user research, which is a counterpart to user experience, and that's what's needed. Because we've received comments from there's one large agricultural association in Portugal, and we made the presentation. This is TerraView OS, and you saw it there in the presentation. They say it's far too complicated. You scared them away. And so that's the big challenge that I see, at least from the agricultural perspective. From the emergency services, I can see a difference thing, but I can't see that technology is one of those things that's helping. That's my bit on it all.
Thank you very much, Andy, and thank you, everyone. We are at the end of the event. I don't know if anyone from the 4 speakers here or anyone else from the previous sections wants to add anything. If you want to say a final remark, feel free to do it now or write it in the chat. If not, we are already almost 10 minutes over time. I apologize, but I think, we went through a very rich type of event. I just want to tell you, we have many other events in EU Cloud-Edge-IoT domain coming up soon. One in particular is focused on a different sector. If you have use cases in energy, don't miss next event. We'll have in a week's time, 29th of February, and Diego will put the link in the chat if you want to follow the other event. Thank you very much for your time, and have a nice afternoon and evening, everyone. Bye-bye. See you soon, and everything will be online in the next days.
Bye-bye. Thank you for today.